Hi, in the following video, we'll cover the remaining questions until the end of this booklet. So if you haven't tried yet, please pause the video and try first.
A few moments later.
Alright, so first question also you need to rely on a ruler. So again, on my screen, the ratio may not be the same as yours. And for the first part here, this on my screen is about 5 cm. And for this one with certain angle, okay, I try my best. This is about 4, but not 4. I think this is 3.5. And the vertical one, I didn't draw very well, but it should be about, yeah, also 3.5 as well. And so that means horizontally, we should get to 8.5, which is about here. Okay, unfortunately, they kind of overlap each other. But I guess that's alright. So then, vertically should be up to this point. So let's just draw a line. Okay, and I'll erase the rest. Oh no, okay, that's fine. Okay, so this is the resultant for the first question. For the second question, again, I will need to measure it. This one is about 5 again, and this one at this point it is about, yeah, I think it's also 3.5. I guess this is just the same vector but got, swing to the left, and vertical is the same, yeah, it's also 3.5. So what you get is 5 minus 3.5, that's 1.5. 1.5 is about here, and the same height, so go around like this. Okay, so that should be the answer, and I'm pretty sure using your own scale is fine, but then you should also end up with somewhere around here and somewhere around here also. 38. Find the magnitude and direction of the vectors with components. So you just have to combine them basically. So for A, then the vector A would then be -4 square plus -4 bracket square. So actually negative doesn't really matter. So that's going to be 16 plus 16 root, so 5.66, let's say. Actually 2 suffix, so just 5.7 then. Alright, and for the angle, tangent theta equals to -4 over -4. So if you just find, yeah, that's going to be 45 degrees. Very simple. Part B is going to be the same thing. Pythagoras theorem, 124 square -158 square. Using your calculator, you should find about 200.8. So I would take it as 201. As for tangent theta, that's going to be the y over the x. Angle will be -52. Actually, 3 suffix, then it's going to be 51.9 degree. Okay, don't forget the units degree. Question 42 is probably the one that you find the hardest among all these questions from my experience. So you have to understand what is asking and also draw the diagram correctly first. So it said there is a particle with certain momentum. It changed the direction by 30 degrees after the collision, but then the magnitude doesn't change. So that's why it is elastic collision, and that's why the velocity is still remaining the same. So what you can do is that let's just call these as vector P, and then after that it changed by 30 degrees. So it's still not exactly the same vector, so I call it P1, P2 maybe, but then they're actually having the same magnitude, and then the angle is changed by 30 degrees. So if you try to find out the change in momentum, and when you say change, that is always nu minus the O, right? Just like how you do in mathematics. When you find percentage change is always nu minus O divide O, right? So what you have to do here, it will be P2 minus P1, all right, would then be the change in momentum. Okay, and so on the graph, that means you have to locate where it is first. So P2 is here, P1 negative would then be the other way around, right? And since you want to find this, then I think we can just, okay, we can actually move it here, and probably you could find, yeah, you can find this. So this is actually delta P instead. But then I don't think this diagram is correct, because when the magnitude is the same, so the length of P1 and P2 is the same, so it shouldn't be that long. Probably the blue line is like that much more, yeah, so the actual delta P is more like this instead. So I don't think there's any easy way to do it. Oh, actually you can do one thing in maths that's called the cosine law. So you can use these two line and also the angle of this, and you can find it. You can do that. But then for me, I'll just go with the usual way that we do. So I guess what I do is I will express delta P as a vector, and then yeah, it's actually a vector, and so we want to find horizontal first. Horizontal would then be P2, okay, or I can say absolute P, which we take the magnitude, and then we can do cosine 30, and then minus 1 of these, okay, and for Y is just the vertical one, so it will just be sine 30 degree, okay. And if you try to find, well, this obviously is like cosine 30 degree minus 1, so that's gonna be negative 0.1339, or simply be 134 of P, and the vertical one is 0.5, because that's only sine 30 degree of the magnitude of P originally. And so if you just want to find the magnitude of the new factor of the change, then the magnitude of this, we're again using Pythagoras theorem, negative 1.34 square plus 0.5 square, and then outside, or I can write at the on the left, right, absolute of P would then be 0.5176, which I will run it to 2 sig fig, I think, so 0.52 only. Alright, so that should be the final answer. Question 44. Allow me to be lazy, because this question I think is really simple, so I'll just call the vectors B, C, and E simply. And so it asks us to find the components of it. So I'll just write down the equation, and you can just press a calculator to find the answers if you like to. So for Bx, it's gonna be cosine. Alright, so I'll say B, vector B with cosine 35, and so obviously the other one must be sine. Alright, the actual reason is that because you are forming it as a triangle, so if one is cosine, in fact the other one must be sine. Alright, and that's also the reason why there's a formula in maths that is cosine theta square plus sine square theta equals to 1, because if you try to apply the Pythagoras theorem on this, you should get back to the original vector, which is B here. So for next Cx, that's gonna be sine or cosine, that's going to be, actually depends on which angle you're taking. I mean, if you're taking this angle, then obviously sine cosine will kind of swap from my answer to your answer. So if I just stick with 68, then it's going to be cosine 68 degree, and so the other one would be sine. And lastly, for this one, EX, wow, this one is a bit hard. I think this angle right here is gonna be 30 degree. Yeah, you can try to work out the geometry. This is similar to the inclined plane question that we talked about in the previous video or in mechanics. And so for this one, then we would take it as vertical actually. So let's just do this one first. This gonna be cosine, and so that's why this one would be sine, and that aligns with what we mentioned too, because x is the one that is going along the plane, y is perpendicular to the plane. So if I get better computer, that means I can get better videos. If I get better videos, that means you can learn better. If you can learn better, that means you get better grades. So support me with, click the link below to support me on Patreon. Question 46. So let's just try to draw a diagram, and we have 12 Newton at 20 degree, and also 14 at 50 degree. Okay, and so I will just call the resultant as R, and so horizontally we got Rx equals to 12 cosine 20 and 14 cosine 50. Alright, similarly we got y, then it's the same, but we change it to sine for both of them. Okay, use your calculator. Okay, and then as usual we find the resultant magnitude through the Pythagoras theorem, Rx squared plus Ry squared square root. That's gonna be 25.119, so round it to 3 6 so 25.1 Newton. Okay, well actually it's force, so I should actually use F. Never mind. So for angle, then it's gonna be tangent theta equal to y over x, so 14.82 over 20.27. Angle would be 36.1807, so round up to 3 6 36.2 degree. Very standard. Alright, because it's so simple, so I'll just show you the answers directly. For part B, you can check yours. So for Fx is this one, Fy is this one, resultant magnitude is 23.4, and the angle is 65.2. So the steps are all the same. One thing that you may be wondering is what about 105 degree? Because when you try to draw the diagram, it's somewhat like these probably, right? For the 18, that one. And so you may be wondering, oh, do I have to make it negative here or what? Or kind of minus 90 and so this angle will be like 15 degree also. Yeah, well, this one is also 15 degree, and then you make it negative. In fact, you don't have to do all these things, right? You can just let it go. And because cosine 105, if you try to press a calculator, is already negative, right? So the mathematical system that we are using already help us to make it negative. So you can just plug in whatever angle it is there. So it is very convenient. So hopefully this example can help you to build up the confidence of just doing it directly. Last question. The only special thing about this question is you have to calculate the components of several vectors together. So So I would suggest you to start with finding out the resultant horizontal and vertical first. So for the first one, that's gonna be a2 plus 3 of the b's, so negative 2 times 3. So this is negative 6 plus 2, so that is negative 4. For y is the same way, so 3 plus 3 times 5, so it's gonna be 15 plus, so that's gonna be 18. So this is something that you could start with. And similar for the right hand side, that one, so our x would simply be 2b, so negative 2 times 2 minus a, so minus 2, that's gonna be negative 6. And for y, it is going to be 3 times 2 minus the 5, so 6 minus 5, that means 1. So to just start with this, and the rest will just be the same as the previous question. Okay, so because of the time, so these will be the answer. That's all for this chapter. I'll recommend you to do the concept map as well, but for this chapter, the chapter 1.1.2.3 I kind of separated, so it's okay, then you can separate this into 3 sections. That's all for the playlist for chapter 1. So I hope you enjoy learning with me so far, and you may think that chapter 1 is quite simple, but I would say please do not overlook the importance of chapter 1. In fact, I believe chapter 1 is the most important chapter of all the chapters that you will learn, because this is really the foundation of physics. In chapter 1, we learn about units, we talk about incidents of people making mistake about units and pay a big lesson on that. Second is about the errors. Without knowing the errors, we basically cannot do any judgment, because the so-called number that you calculate in IGCSE is just a number, but then we don't know how confident or how valid or justified it is without the error propagation or the map, the graph also. For factor is basically everywhere in all the chapters. So this is actually a very important chapter which you get to use it in the future as well. I will see you again in other chapters. Bye.